just dropped everywhere. How many did we have?
Right there's
3
a
or
thing.
4?
Right here's a thing.
You had 3 exams, yes.
Oh.
Okay, so the first 2 questions are naming ionic and molecular compounds from their formula and then writing formula from their names. So that was exam 1 topic, and let me see what examples, what were the questions from that part I gave you. Question number 4 and 5. Give correct chemical name of the following compounds and then give the chemical formula of the following compounds. So, 1 and 2, I'm using those numbers from your study guide, okay? 1 and 2 means 1 and 2 of your study guide. So, where is that sheet? Right here. So first one is naming from their formula. So I will give you the formula and you want to write the names. So let's see what were the formulas I have given you. So here your examples from exam 1, N2O4, and then you had Na2CO3, and then you had HClAQ. Let me put one more. You have, okay, here are 4 compounds. I am giving you the formulas. We want to write the names. Okay, so first we need to realize whether it is molecular compound or ionic compound, because they have different rules. Molecular compounds, how do you differentiate first of all between ionic and molecular? Metal. If there is a metal, it is ionic. If compound is made of completely non-metals, then it is molecular. Okay. So the first one is molecular or ionic? It is molecular. It is N2O4. So both are non-metals. Okay. Now, when we write the names of the molecular compounds, remember we have to use the Greek prefixes to specify the number of atoms of each element. We don't have any other rules. All you need to do is just remember the Greek prefixes. 1 through 10. Mono, di, tri, tetra, penta, go on. Hexa for 6, hepta for 7, octa for 8, nona for 9, and deca for 10. Remember that. I won't ask you anything with more than 10, okay? So all we need to do is use those to specify the number of atoms of each element. And remember, the second element's ending will change to "ide." Okay? Okay, so how do we name this? How many nitrogens are there? 2. So we will write dinitrogen. How many oxygens? 4. So the word is tetra. Okay. Oxide. All right. Even if you write this way, fine. What is a little bit wrong in here? Concept is completely correct. It's just yes, this tetraoxide. Remember when we said if you have 2 vowels coming together, then you would usually eliminate that. So you will write basically tetroxide. Okay, that is basically tetraoxide combined together. That's why I said it's okay. Okay, if you forget to do that and if you write tetraoxide, I'm not going to deduct any points. But remember, no. But keep in mind that the correct way or the 100% accurate way is writing tetroxide, like decoxide, tetroxide, monoxide. Okay, when A and O comes together, you eliminate A and just use the O. Okay, so for molecular compounds, remember that's the rule. You will use the Greek prefixes. How about the second one? Na2CO3, molecular or ionic? Ionic. It has a metal ion. Okay. So for ionic compounds, how do we name? Positive ion first, negative ion second. Once again, positive ions does not change the ending to anything. You will write the name as it is from the periodic table. Which is this positive ion here? Sodium. So the first part of the name is sodium. Do I write disodium or anything? No. Remember, those Greek prefixes are used only in molecular compounds. Never use them with the ionic compounds. Okay. Now, what is that carbonate? Oh, I'm telling the name. What is the CO3? Carbonate ion. Remember, I told you, you don't have to memorize all the polyatomic ions. Just remember the main ones which were given in your book in big fonts, the bold font, okay? Bold-faced ones. Like carbonate, CO3 2 minus, sulfate. What is sulfate? SO4. What is the charge?
Negative. Positive. 2.
Negative, but 2 negative. Okay, remember the charge. So, the only one positive polyatomic ion you will see is ammonium ion, NH4 plus. Other all polyatomic ions you will see are negative ions. Okay, so sulfate 2 minus, phosphate, another important one. What is the formula? PO4 3 minus, and how about nitrate? NO3 1 minus. So nitrate NO3 1 minus, nitrite NO2 1 minus. Remember, the 8 ending represents the larger number of oxygens. Ite ending, ITE, represents the smaller number of oxygens. So NO2 minus and NO3 minus. NO3 minus is called nitrate, NO2 minus is called nitrite. Sulfate, SO4 2 minus, sulfite, SO3 2 minus. Phosphate, PO4 3 minus, and phosphite, PO3 3 minus. What else you will see? Carbonate is important. Any other polyatomic ion we often encounter? Which one? Hydroxide, yes. OH minus is hydroxide. Chlorate series, yes. Perchlorate, ClO4 minus. Chlorate, ClO3 minus. ClO2 minus is chlorite, and ClO minus is hypochlorite. So that's all the polyatomic ions you need to remember. So this guy, how do we finish this name? Sodium carbonate. How about HClAQ? Whenever we see AQ in parentheses along with a formula, what does that represent? Aqueous means it is dissolved in water, but when I give you for naming, it is an acid. Remember, all the acids we will write with an AQ in parentheses, right? So this is, well, for the binary acids you have to use the word hydro in front. Binary acid means what? There are only 2 elements in it, hydrogen and something else. This is hydrochloric acid. Just like that, you will find hydrobromic acid, hydroiodic acid, or hydrofluoric acid. Okay? Well, when you have polyatomic acids like H2SO4AQ, do we use the word hydro in front of it?
Yes.
No, we don't. This is not a binary acid, remember?
I thought you meant the HCl. Yes, we do.
No, binary acids only use the word hydro in front. Acids with more than 2 elements. Here there are 3 different elements in here, right? So that is not a binary acid. They do not use the word hydro. The naming comes just from the polyatomic ion's name. This is we don't use the word hydro at all. That's what I keep saying. It is understood that hydrogen is present. You don't have to say it again. So what is this polyatomic ion? Sulfate. So the ending will change to sulfuric. Sulfuric acid. Ending will change to ic.
That's hydrogen because it's binary.
This is binary because there is, the HCl is binary because there is only hydrogen and one other element.
Right.
Only two. So we have to use the word hydro. You cannot just say chloric acid. Okay? When you say chloric acid, it's a different acid. It's not HCl. Perchloric acid means, what is perchlorate ion? ClO4 minus, right? So when that minus charge is balanced with a hydrogen, this is called perchloric acid. Because once again, this is a polyatomic acid. It's not a binary acid. So you just focus on the, it is perchlorate becoming perchloric acid. Just like sulfate becoming sulfuric acid. Exactly. Yeah. It is an acid, and when you see H and AQ, that means it is an acid. This is perchlorate ion, therefore it will be perchloric acid. What is the? Per comes from this hydrogen part. This name of this ion itself is perchlorate. What are you guys talking about?
Does Boston cream pie have cream cheese in it?
Oh my God. Okay.
Does Boston cream pie have
No.
cheese?
No, it does not.
I don't know what is the ingredients in Boston cream, so I don't think so. So keep that in mind, guys. Binary acids only will use the word hydro, okay? Other acids, the name comes from its polyatomic ion. So focus on the polyatomic ion, change the ending to ic, sulfuric, perchloric, carbonic, if it is carbonate, okay, like that. Okay, so this one we will name as hydrochloric acid.
Oh, you don't put the hydrochloric together?
You can put together, that's fine. Even if you give a little bit space, that's also fine. How about PbO2?
Lead.
But Pb is lead, yes. Okay. Someone says lead oxide. Yes, it is lead oxide, but it is not complete. What's missing? No. Is that an ionic compound or molecular compound? Ionic. So do we use any of those Greek prefixes? No. So what is special about lead oxide? What is missing in there? Remember, if your metal ion is from the transition metal series, you need to indicate the charge in Roman parentheses. Roman letters in parentheses after the name, because lead can have varying charges. Transition metals, they can have varying charges, right? Remember the main group metals, that is group 1 always will have 1 plus, group 2 always have 2 plus, group 3 boron, aluminum always have 3 plus. So if they are your metal ions, you don't have to write the charge in parentheses because they cannot have any other charge. But transition metals can have varying charge, so you have to write the charge in the Roman letters in parentheses. So what is the charge of lead here?
2.
Okay, everyone smack yourself.
1.
Oh, now are we doing 1, 2, 3, 4 until we hit the correct number? No. How do we figure out? How do we figure out? Remember, the formula has a neutral charge, right? So that means looking at the negative ion, you can figure out what the charge on lead. What is the negative ion here? Oxygen. Oxide, what is the charge of oxide? 2 minus. How many oxygens you have there? 2. So how many total negative charges you have there? 4. So 4 negative charges should be balanced by 4 positive charges, and 4 positive charge should come from the positive ion here, which is lead. How many lead you have? 1 lead. So that 1 lead should be 4 plus. So what do I write here in parentheses?
1B.
Okay? Alright, one more for that practice. Give me the name of this compound. Fe2O3.
Fe's iron.
Fe is iron, yeah.
No.
It's not iron too.
Go with
Don't get this number indicate the number of iron in there. What we need is the charge of iron in there. How do you figure out the charge? Okay. All you have to do is, guys, it's very simple math. You look at the negative ion, they have fixed charges. Negative ion is oxygen here. There are 3 oxygens. So what is the total number of negative charges? 6 negative charges, right? So to balance that, you need 6 positive charge. The 6 positive charge should come from 2 Fe's. Fe2 means there are 2 Fe's, correct? So 6 positive charge should come from 2 Fe means what should be the charge of 1 Fe? How much 1 Fe will contribute? 3. So you have to put 3 in parentheses and then you write oxide. So once we do this, you can look at the reverse process also. That is, if I give you the name, how do we write the formulas? Do you want different examples? Probably that would be a good idea. Hydrochloric acid is molecular. All acids are molecular, but they don't follow the Greek prefix rule. Acids have different rules. Okay, so I have writing formulas. What? Why is that oxide? Because it is oxygen.
It's not molecular.
It is not molecular. Only for molecular you use the Greek prefixes. For ionic compounds, do not bring Greek prefixes. Okay, so for writing chemical formulas, what examples I had from your exam 1 is, well, oops, come on. Maybe I'm too down to the, so they won't let me write there. Let me put it here. Ah,
I put
that's a 3, guys. I know. It sounds like,
for iron, I put I. Alright, glad I can laugh about that now.
yeah. Okay, so the first one is carbon tetrafluoride. Carbon is what? C. There is no number in front of carbon. What does that mean? How many you have? Just 1. If there were more than 1, then you would write di or tri, whatever, right? So there is only 1 carbon. So we have, what is, okay. So there is 1 C. Tetrafluoride. 4 fluorines. What is fluorine? F and 4 of them. CF4. How about nitric acid?
HNO3.
Yes. How do you get that? So, and remember you need to put an AQ in parenthesis just to specify that it is nitric acid. So remember when we say nitric acid, the word acid means it has to have hydrogen. Okay? That's, every acid has hydrogen. So hydrogen will be there. Now you have to see, nitric come from which ion?
NO3.
The nitrate ion, which is NO3 minus, right? Remember, hydrogen here act like the positive ion to balance the charges. So if NO3 is 1 minus, how many hydrogens you need to balance that? 1 hydrogen, because H is H plus. In acids, remember, H is acting as an H plus. So nitrate takes up 1 hydrogen and H plus becomes HNO3 neutral, and that is nitric acid. Okay, how about iron 3 sulfate? Let us identify the ions first. Iron is Fe. This 3 indicates that iron is 3 plus. Okay. What is sulfate ion? SO4 2 minus. Now come up with the formula when they are equal in charges, equal positive charge and equal negative charge. You like to swap, yeah, whichever way, you swap them or you work out, okay, 3 positive and 2 minus, so the common multiple is 6, and how to get 6 positive and 6 negative, that also will work, whichever way you want. There are 2 methods to do that. So if you are swapping places, remember this number will go for SO4 and this number will go for Fe. So you can write Fe2 and SO4. I need to write 3. How do you write 3? Put sulfate in parenthesis and write 3. So that is the formula. If you are working on charges, when it comes to 2 and 3, the easiest way to do it, the common multiple of 2 and 3. Which is the least common multiple of 2 and 3? 6. 2 times 3 is 6. So you are going to say, if I can have 6 positive charge and 6 negative charge, this compound is going to be neutral. If one ion is 3 plus, how many ions you need for 6 positive charge? 2 of them. So you get Fe2. If one sulfate is 2 minus, how many sulfate you need for 6 negative charge? 3. So sulfate 3. So this comes from the concept that in a compound, the charges has to be balanced. Total number of positive charge must be equal to the total number of negative charge, thereby giving the compound a 0 net charge, or compound is neutral. All right, so that is back and forth, either from the formula to the name or from the name to the formulas. Okay, which one are we doing next? Let me get another screen. I think writing molecular ionic and netionic equation, which is number 5 on your study guide. That must be from exam 2, I believe. Is it? Yes. Exam 2. No, we are not, because we don't have time to do everything. So we are just selecting stuff. See, we don't have much time. So writing ionic, netionic, you have the question given in exam 2. I'll take one question. PbNO3 twice. PbNO3 twice AQ plus Na2SO4. Okay, so this is what will be given in your problem. That is 2 of the reactants, both their physical states. That much will be given to you. Okay, you have to complete the equation, balance it. You will be given solubility table or solubility rules, so you can figure out what are the physical states of your product. That will give you the molecular equation. Once you have the molecular equation, very easy to do ionic and netionic. So let us complete the equation. Every equation I will ask you for this type of questions are going to be double displacement or metathesis reactions. So what are the products? What are the possible products? Swap the ions. Pb, why Pb2? Look at the charges. Pb has 2 nitrates ion. That means what is the charge of Pb there? Nitrate is, what is the charge of nitrate ion? NO3 is minus. There are 2 of them, means there are 2 negative charges there and only 1 Pb. So Pb has to be 2 positive. And it is taking SO4. SO4 is what? Negative 2. So 1, 1 each is good. They are balanced. Pb2 plus and SO4 2 minus. So the formula is PbSO4. Well, we don't know the physical states yet. Let us figure out the other compound. What is the other compound? 2NaNO3. Good. Because Na is plus 1, NO3 is minus 1. Right? Well, 2 will come when you balance, but the other compound will be NaNO3. Now when you look at the equation, we will see that right now it is balanced, but when you look at the equation, you will see that there are 2 nitrates and 2 sodiums on the left side. So you will have to place a 2 in front of NaNO3 to balance the equation. Well, now look at the solubility rules and tell me which one is what. What is the physical state of your products? PbSO4 is a solid or liquid or gas or aqueous? What are the rules for sulfates? If anyone has it in the book, please read.
Does anybody remember what page it is?
Do you have the book page, Bethany? 121. And what is it? What does the rule says about sulfates?
Soluble except in SR2 plus, PA2 plus, AD22 plus, and PB2 plus.
Okay, so sulfates are mostly soluble, but there are exceptions, and Pb is one of the exceptions. That means, yes, I will give that chart. You don't have to worry about memorizing them. So what does that mean? PbSO4 is
Solid.
a solid. And how about NaNO3?
Aqueous.
Aqueous. Nitrates, all nitrates are soluble. So this is your molecular equation. So when you say molecular equation, basically complete the equation with the products, write their physical states and balance. Yes.
So just a quick question. The sulfate is solid, the lead sulfate, whatever,
Hmm?
is a solid because sulfate is not soluble in lead?
Not soluble in lead. Sulfates are mostly soluble, but it is, when it is with lead, it is insoluble.
Okay, so those are what the exceptions are.
Yes.
When it's with this, it's not soluble.
Exactly. Now once you have the molecular equation, what do we mean by ionic equation? What do you do for ionic equation? You break everything up, but what do you break up? Do you break everything? No. You not only that, what you have to remember is you will break only the species which are aqueous. Solid, liquid, gas, do not touch them. Okay? They do not dissociate. Only aqueous species will dissociate. So whatever you see with aqueous, you have to split. That is why it is important to look at the physical states of your products and write them clearly. Otherwise, you don't know which one to split and which one you should not touch. So, lead nitrate we have to split because that is aqueous. What are the ions? We already discussed that. What are the ions in lead nitrate? Lead and nitrate, but we have to write them with charges. Pb2 plus Aq and 2NO3 minus Aq. Okay, how about Na2SO4? What are the ions?
2Na plus
2Na plus ion
this
and
SO4.
SO4 2 minus. Good, we are done with the left side, going to the right side.
SO4.
Do I touch PbSO4? No, it is a solid, so write it exactly as it is. Don't do anything. Plus, how about NaNO3?
2Na plus
You have 2Na plus Aq and 2NO3 minus Aq. This is your, what do we call this equation?
ionic.
This is your ionic equation because everything aqueous has been split into its ions. Now you want the net ionic equation. How do you get net ionic equation from ionic equation? What do you need to do? Cross out the spectator ions. So what are spectator ions? How do you identify them? Ions existing on both sides, exactly as it is. So check one by one. Pb2 plus Aq. Do you have Pb2 plus Aq on both sides?
No.
No, you don't. 2NO3 minus. Yes, you do. So you have to cross that out, both sides. How about 2Na plus? Yes, cross that out. And SO4 2 minus is not there. Can I just keep it?
No, game should just say, oh, I got PbSO4, so I just keep those ones.
Well, that's one way of looking, but you have to actually cross out. What if the question is asking what are the spectator ions? Identify them.
I can do that.
Yeah, okay. So what are we left on the ionic equation now? After crossing out the spectator ion, that makes the net ionic equation. So you have Pb2 plus Aq and SO4 2 minus Aq forming PbSO4 solid. That is your net ionic equation.
So we have spectator ion also.
Say that again.
One's called spectator, one's called...
The others are actually ions which are participating. So just eliminate the spectator ions. Okay. Limiting reactant problem. Again, exam 2, I believe.
Fe and alpha.
Exam 2 or exam 1? Say that again. What did you ask? Yeah.
Iron and alpha and beta.
Iron is a transition metal. Alkali metals are the group 1 metals. Alkaline earth metals are the group 2 metals. Let me see. I think it's in exam 1 itself, guys. Limiting reactant problem is in exam 1 itself. Okay. So that will be question number 10 in your exam 1. Let me pick up a screen and let us do that problem. And white screen, and this is which one? 6 on your study guide. So the question here was 2 Mg plus O2 gives 2 MgO. This is the equation given to you, and the question was if you have 24.2 grams of Mg and 35.4 grams of oxygen, 35.4 grams of oxygen. These are the information given to you. That's all is given to you. You have the balanced equation.
This is limiting reactants.
Yes. And then you have the amounts of both reactants in grams. The question, there are 2 parts of this question. First part is, which is your limiting reactant. Second part is, how many grams of MgO will form. Okay? Well, in your exam, there was a part 3 also to calculate the percent yield. Which is easy, because I will give you the actual yield. So, but these are the 2 points where you have to focus on. This is the tough part. So, whenever we see gram quantities, can we do anything with grams? No, it must be in moles. So, the first step is converting both grams to moles. How do you convert grams to moles? You must have done this 1,000 times now.
Divided by the molecular.
Divided by the molar mass. Okay, so do that please. So 24.2 grams of magnesium. How many moles you should get? 0.995. Yes. So 24 point, do you want me to write down the step? Okay. 24.2 grams. Division is the same as multiplying by the reciprocal. So I'm doing that so that I can cancel the units. And molar mass of magnesium from periodic table, 24.31 grams. So grams and grams will go away, and that will give me 0.995 moles. Now same thing for oxygen, 35.4 grams multiplied by 1 mole per molar mass of O2. Keep that in mind. Your reactant here is O2, not just O. So when you take the molar mass, you need the molar mass of O2, which is 32 grams. So grams goes away and you will get
How did I get that one?
1.1063 moles. So these are the two mole quantities, 0.995 and 1.1063. Now we can identify which is the limiting reactant. Remember, for limiting reactant, pick up the first one. Doesn't matter which one you choose, but normally just pick up the first one, which is magnesium, and you have 0.995 moles of magnesium. Figure out how many moles of oxygen actually you will require using the mole ratio from the balanced equation. What is the mole ratio between magnesium and oxygen in the balanced equation? 1 to 2. Well, magnesium and oxygen, so 2 to 1. So when you use the mole ratios, this is the number of moles of magnesium you have, correct? So put that number on the denominator. So you have 2 moles of Mg per 1 mole of O2. This information comes from your balanced equation, the mole ratio. So that means how many moles of oxygen actually you need for this reaction? 0.497, well, I can say 0.498 moles of oxygen. This is what you require, right? Now compare what you have given in the problem with what you require. You require 0.498 moles of O2. You are given 1.1063 moles of O2. So what do you say? O2 is excess or limiting? O2 is excess. Once again, this is the logic. You need only this much for the reaction, right? What you calculate using the mole ratio, that is what you need. You need only 0.498 moles, guys. You are given almost double the amount, more than double the amount. This is what you are given in the problem. So that means this is excess reactant, and that makes magnesium the limiting reactant. So magnesium is limiting reactant, O2 is excess reactant.
Okay, I'm a slow writer. What's that bottom equation right there?
This is calculating how many moles of O2 you require using the mole ratio.
2 moles of Mg opposed to 1 mole of oxygen.
That is the mole ratio. Once you identify the limiting reactant, keep in mind amount of limiting reactant determines the amount of product that can form. So now you are focusing on, yes, from the balanced equation. That is why you need the balanced equation. Look at the numbers given before each formula. That is the number of moles in the balanced equation. Okay, so you have magnesium, the limiting reactant. How many moles of magnesium you have? 0.995 moles of magnesium. And now we need to know how many moles of the product can form. So what is the mole ratio? 2 to 2 or 1 to 1. So 2 MgO per 2 mg. That's what the balanced equation says, right? Or in other words, how many moles of the product you can form? Exactly 0.995 moles of MgO. This is what you can form. Is the question asking how many moles of MgO will form? No, the question is asking how many grams of MgO will form. So we need to convert this moles to grams using molar mass of MgO. What do you need to do with the molar mass? Multiply by the molar mass. So multiply the molar mass of MgO will be 40.31 grams per mole. So mole and mole will go away and you will have your answer in grams, which should be 40.12. So that is the amount of MgO that can form in grams.
So whatever the limiting reaction is, it's not going to be moles.
No.
Right?
Limiting reactant is calculated using the mole quantities. What exactly is your question? You don't know?
40.31 grams.
Molar mass of MgO. Because that is your product. The question is asked. No, it's just the molar mass of 1. The mole ratios comes, those numbers represents only the mole ratios. You need them only in the mole ratio. When you do the molar mass, remember you are just looking at one formula unit. Okay? Guys, feel free to come and eat again because you have so much food in here. Okay.
There's weed in these.
Moving on.
Do you want one? She doesn't care.
What?
There's something special in the brownies if you want one.
They're special brownies.
What are they?
Weed brownies.
Weed? Oh my! Vinny is not here, guys. So who brought it?
Just
Oh my. Derek. If not Vinny, then who else, huh? Okay, number 4 was calculating the enthalpy of formation and calorimetry. Where is my pen? Okay. So, enthalpy of formation, that must be exam 2.
number 5.
3 will be calorimetry and number 5 is actually Hess's law. Enthalpy of formation is, where am I looking? No, not 8.
Yeah, number 8.
Number 8.
It's 10.
Which exam am I looking? Exam 2. Exam 2, 10. Okay, the reaction will be given to you and delta H formation of each substance will be given to you. You have to calculate it for the whole reaction. So this is basically algebra, guys. All you need to remember is products minus reactants. That is the rule to remember. So delta H formation of, the reaction, remember that formula, sigma n into products minus sigma m.
This is 8, right?
Yeah.
Yeah, this is 8. What do you mean?
Yeah, number 8 on the study guide.
Oh, okay, study guide. That is, I know what I mean.
You're writing chapter.
No. I wrote 4 because that was 4th request. So I wrote down 4 next to 8 and I just wrote 4 there. My mistake. That is number 8 on your study guide. So all you need to remember is that, and then I will be giving you the table like that, whichever reaction it is. Okay? I will give you the balanced equation because I don't trust you to balance the equation there. If your balancing gone wrong, then even if you do your math right, your number will be wrong. So I will give you the balanced equation and the table with the individual values. All you need to do is just, yes, the sum of n represents the moles. Here also m represents the moles. The sigma sign represents a sum. Exactly. So products minus reactants. That's all you have to remember. Do you want to write down the problem now from your exam too?
Yeah.
Okay. So the equation was CaOH, OH twice plus 2H3ASO4 giving you CaH2, oh, where is the Ca disappeared? H2ASO4 twice plus 2H2O. Now I'm not going to copy the table right now. For each of those 4 species, I have given you the values with the sign. So all you are doing is, these are your products, these are your reactants. So the product numbers first, CaH2ASO4 twice. The number is given as negative 2346. So negative 2346, there is only one of them, so we have to use that number only once. Negative that, and how about the next one, that is water, and water is also negative, so definitely that number is also going to be negative, right? So 2 of them, so negative 285.9, but this number has to be multiplied by 2 because you have 2 water in there. So this is your product side, right? Minus, now come down with the reactants. So calcium hydroxide, there is only one calcium hydroxide and the number is negative 986.6. And then the other reactant is H3ASO4. There are 2 of them and the number given is negative 900.4. So negative 900.4, multiply that by 2. This represents your products minus reactants. All you need to do now is take out your calculators and do that math carefully.
But it's negative 130.4.
Answer is negative 130.4 if you do the math correctly.
Which numbers belong to which?
As it is written, these are the products, right? So the first number represents the first product, 2 times water, so that is what is 2 times this number, minus this number represents calcium hydroxide, and then 2 times this number, 2 times that compound. So those individual values are given in your exam booklet itself. All you need to do is just remembering that product minus reactants, and the balanced equation is also given to you, so carefully put the numbers in.
This right here that we just wrote, do out that math and then it equals the change in heat.
That represents the delta H formation of the reaction.
The whole thing, and that's all it is.
Yeah, when you just solve this, you will get negative 130.4, and that is your answer. Well, these are all given in kilojoules, therefore your unit will be kilojoules. That's why I said this is one of the easiest. All you have to keep in mind is products minus reactant, that is the order, not reactants minus product. Okay? Now another part of this question could be calorimetry, which will be question number 3 on your exam 2.
Are we doing like number 9?
Well, let's just do this one. At least let's just finish this one, then we will do 9. Okay? So for calorimetry, guys, all you need to remember is that one equation. What is the calorimetry equation? Now, calorimetry, Q is
Over
MCS delta T. M represents the mass, CS represents the specific heat, delta T represents, delta T means what? Change in temperature. That's all you need to know for the calorimetry. And so there are 4 quantities, Q, heat, mass, specific heat, and delta T. 3 will be given to you in the problem. You will be asked to calculate a 4th quantity. So just substitute the numbers into its place and you should just do the math. Q is heat. Q represents heat.
So you just set up for CS equals Q over M times change in C.
Yeah, this is specific, but this is the parent equation. That's why I wrote that way. And then difference in temperature. Now you can rearrange this equation in any way. If I am asking you to solve for specific heat, then you can rearrange that equation as Q divided by M delta T. Right? If I am asking to calculate mass, then you can rearrange that as Q divided by Cs delta T. If that is the beauty of this parent equation. If you just know this equation, rest is just the simple algebra. Rearrange the equation for whatever you are asked to solve. Okay, what next? Writing complete and abbreviated electronic configuration. We are focusing only on ions. Ooh, we don't have much time. See how fast the time goes?
Like too quick.
I know. So for ions, we need electronic configuration for ion. What was that question? Number 10 on your study guide. Let's say we want the electronic configuration of, I'm just putting examples now, no time to look for examples. Fe3 plus and S2 minus. Let's take a positive ion and a negative ion. So Fe3 plus means, remember in electronic configuration we are indicating the number of electrons, correct? Fe's atomic number is 26. 3 plus means how many electrons Fe has? 23. So make sure you will write the electronic configuration until you have 23 electrons. So 1s2, 2s2, 2p6, 3s2, 3p6. Ion is in the fourth period, right? So 4, and if you were to write for up to 26, you have to do 4s2, 3d, 1, 2, 3, 4, 5, 6. I can't even. 1, 2, 3, 4, 5, 6. So let me write the full first. So you will write 4s2, 3d, 6. Correct? This is what the electronic configuration of normal ion or neutral ion. Now remember, when they form ions, electrons are lost from the last filled principal energy level first. So 4s will go before the 3d. Okay, because the last filled principal energy level is level 4 here. Even though when we write 3d afterwards, because when we write we are following the energy levels, but when the electrons goes we are following the last filled and principal energy levels. So the last filled principal energy level is level 4. So first this 4s2 will go. Remember, we need to remove 3, right? From 26 we have to remove 3 to get Fe3 plus, correct? So remember, Fe was just 26, Fe3 plus is 23, so we need to remove 3. So the 2 is gone from 4s2, we need to remove one more. That will go from the 3d. So the 3d will become 3d5. So that will be the electronic configuration of Fe3 plus. Now for the negative ions, let's say S2 minus. What is normal sulfur? What is the atomic number? 16. So if you write the electronic configuration, 1s2, 2s2, 2p6, 3s2 and 3p, 1, 2, 3, 4, 3p4. You already added. I'm writing for the normal sulfur. I'm going to show you what happens in S2 minus. This is normal for sulfur, 3p4. S2 minus means how many electrons you have? Normal sulfur has 16, S2 minus has 18. So you need to add 2 more electrons. Where will that go? To the last filled level, which is 3p. Note that in 3p it's only up to 3p4. P can take maximum 6. So this will become 3p6. Okay, let's do at least one more, guys.
Yeah.
Are we doing
Okay
it
with
where you
doing
take it away? We just did, I don't, when you take,
the highest goal.
when you're taking on.
That's what we just did for the positive one. You take 4s2 away and then you take 1 away from 3d5. I mean 3d6 you take 1 away, so you get the 3d5. That is for the positive, taking electrons away. Okay, so this was marked as 10. The next one marked is hybridization. Is that what you want to do?
Hybridization?
Yeah?
Sure.
Okay. That was 13 on the study guide.
What would be asked about phase diagrams?
That's what we just heard.
We just did that in last class. I will give you a phase diagram. You need to know what are the regions, what are each lines represents, what are the points represents. Like you need to know where the triple point, where the critical point is, where is solid, gas, liquid and supercritical fluid phase. Yes, label the diagram. So look in that general phase diagram of your book and you need to memorize, you know,
Water.
not for, I mean it could be for anything, you know, as long as you know that, yeah, it is, every phase diagram is the same format.
Either strings.
Exactly.
Do a phase diagram and be like, what is this? Like, what phase diagram is this?
No, I won't ask you for figure out which phase diagram is this for which compound. I won't say that. All I want you to know is you need to know on the phase diagram what are the points, where are the four phases and what each line represent. Like when you put the arrow this way and this way, what are those processes like melting, freezing, vaporization, sublimation, deposition, those things. Where are they on the phase diagram? That's all you need to know about the phase diagrams.
We need to know what
Each area represents, yes, you need to know where the solid is, where yes, on the axis, pressure, temperature, and then where each things are. Solid is where, liquid is where, gas is where, like that. Focus on that general phase diagram on your book. Okay? That will give you all the information. Okay, hybridization. Hybridization, guys, they are so connected with the parent geometry. Okay? So what are our parent geometries? The electron domain geometries. When you have two pairs, you call linear. When you have three, you have trigonal planar. When you have four, tetrahedron. 5 is trigonal bi. I always get confused with that spelling. And when you have 6, so these are the basic geometries, right? Electron pair geometries. From here comes your hybridization. If you have only 2, then you should have only 2 in your 2 hybrid orbitals. Only 2 hybrid orbitals. That means you have just sp, 1s, 1p. There are 2. When you have 3, you need 3 hybrid orbitals. That means s can have only 1. How many p can have? A maximum of 3. But you need only total 3 here. So how many p you should have? sp2.
Let's talk about the boxes. You know,
Yeah, that box represents each how many p can have. P has 3 boxes.
I'll look back at my test.
How about tetrahedral? You need 4 orbitals here. So s and 3 p's. So total 4. Okay. How about trigonal bipyramidal? sp3. One more. d. Octahedral will be sp3 d2. Remember that. That number of electron domains will tell you what is the domain, the parent domain, and what is the hybridization. Now, the actual shape could be different from those names. Hybridization will not change. Hybridization comes from the parent domains. Okay? Hybridization always comes from the parent domains. Once you decide the parent domain of a central atom, you can write the hybridization immediately. Actual shape will be different. Actual shape you have to actually look at, is there a lone pair on it? If you have a lone pair, you have to remove it. So what are the derived shapes? What are the derived shapes of each? Do linear have any derived shapes? No. How about trigonal planar? Bend. It is a derived shape from trigonal planar. You have 3 electron domains. If one is a set of non-bonding pair, then you can have the actual shape as bend. How about tetrahedral? Trigonal, pyramidal and bend shape. Okay. How about trigonal bipyramidal? Go in the order. When you remove one, you have seesaw. One more, T-shape. Then you have,
Oh,
yes, you have linear. Because remember, trigonal bipyramidal, 5. In that 5, 3 are equatorial and 2 are axial positions. Lone pairs occupy the equatorial positions. Okay? They prefer the equatorial positions. So you are removing one by one from the equatorial positions to get seesaw, T-shape and linear shape. Okay, octahedral can have what else? When you remove one, you get square pyramidal. When you remove one more, you get square planar. That's all about the geometry and hybridization. Keep in mind, hybridization is decided by the parent geometry, not the actual shape. What? Well, yes, approximate angles. Okay. People who can remember exact, good. At least make sure you know less than or greater than. At least you know that much. Okay. I guess I have to stop right here because we need to do the evaluations. Okay, so you all have done this before. You don't need any explanation, right? You all have done it before. Okay, who is going to take it? All right, wonderful. And you guys know where to give it also. I'll fill my plate and walk away. Thank you guys. Go home and study well. I want everyone to do well in the final. Okay? Oh my God. Take some more stuff, guys. I don't want to take all the cookies. Okay. You know what? I'll just put everything in this plate and I'll just take my plate so that you guys can take some home. Anyone wants more chocolate? Yeah. Okay.
Do you want to take one of those things home with you?
I'll make a plate for me. I mean, I have my plate empty, so I'll put a plate full of chocolates here.
you can use a pencil, right?
What? Just remember to completely shade the circle. I think pencil or pen is fine. Oh my, a lot of things in here. What? Oh, cool.
Hopefully we're
And it's still recording. Thank you, Missy.